All right, we're going to start talking about key features of the basic exponential growth and basic exponential decay function. So as a quick reminder, I'm going to go ahead and zoom in here. So let's go ahead and talk about exponential growth. So the function is going to be f of x equals b to the x, where b is greater than 1, right? So again, any value greater than 1 will work, but it has to be something greater than 1. Even 1.01 is an exponential growth function. What does that graph look like? So I just drew a quick little XY coordinate grid. Basically, the graph is going to be an increasing graph that's going to curve up. All right. Now, this curve down here is going to get progressively closer and closer to the x-axis as we move towards negative infinity. And as we move toward positive infinity, this graph is going to keep going up. All right. Domain here. When we look at domain, we want to look at the possible x values. And all x values are possible. So negative infinity to infinity. The range is bottom to top. What are our possible y values? Now, if we look at the graph, we can kind of see there's no negatives. And this curve is never going to touch the x-axis. And the x-axis has a y value of 0. So we're going to go from 0 to infinity. But be careful because this 0 is going to take a parentheses, meaning we can't actually be equal to 0. All right, so that's the domain, that's the range. All right, asymptotes. There is one asymptote. I'm going to go ahead and put it in highlighter here. I'll zoom in on that, and I want to make the highlighter a little bit smaller. The asymptote is going to slide right along here. And what this asymptote is, it is the guide that we are going to, this curve is going to approach this asymptote, but never actually touch it or cross it. That horizontal line is the line, let me grab a pen here, y equals 0, right? Y equals 0 is that horizontal line. All right, what's next? X-intercept. Well, x-intercept would be where do you cross the x-axis? And the answer is you don't. So x-intercept, none. All right. Now, we do have a y-intercept, all right, and the issue is maybe we don't know where. Well, technically we actually do, because every y-intercept has an x value of 0. So if I do b to the 0, that's going to turn into 1. Right? It doesn't matter what b equals. Any value raised to the 0 power is going to be the value of 1. So that tells me that my y-intercept is 0, 1. And that will always be that way for exponential growth. Last thing, oh, nope, I lied. 2 things. We've got interval of increase or interval of decrease. So I'm going to go back up to the graph. I keep kind of scrolling back and forth here. This graph is constantly increasing. Now, in the beginning part over here on the left, it's not increasing very fast, but it is still increasing. So when we look at the interval of increase for an exponential growth function, it's the entirety of the domain. So I'm going to go ahead and slide down to interval of, so this is going to be increase. And yes, you do want to specify which one. So increase from negative infinity to infinity, right? As we read this graph from left to right, it is going to constantly be increasing across. All right, last but not least, yes, it is. Okay, I said it right this time. End behavior. It's been a little while since we've talked about it. So remember, it's going to be as, apparently I need to remember it. So as x approaches infinity, did we give this thing a name? I did. I called it f of x. So I'll go ahead and call it f of x. F of x approaches something. And then the other half of it is going to be as x approaches negative infinity, f of x approaches something. And we need to fill these two somethings in. So let's look at this graph as we look to the right. And I'm just going to do myself a favor, and I'm going to put a little sketch down here. This way I don't have to keep kind of scrolling back and forth. So this sketch is going to look something like this. All right. So as x moves to infinity, right? So we're moving to the right here. This function, this green curve, is moving up. And in that case, we're talking about possible y values. So that's going to be positive infinity. And then as x moves towards negative infinity, that's going to be to the left here, f of x is approaching, well, f of x is approaching 0, right? This y value here is 0. It won't actually touch it, but it's going to keep trying to get closer and closer to it. So that is all the key features for the basic exponential growth function. So now I'm going to go ahead and slide on up, and we're going to repeat the process, but this time let's talk about basic exponential decay. So I'll call this one g of x. And for g of x, it's still b is, b to the x is the function. The difference is we need to get b trapped less than 1 but greater than 0. All right, that has to be the true part for exponential decay. So what might it look like? Well, let's go ahead and draw a little sketch here. Exponential decay is going to be a decreasing function. All right, so basically you want to decrease very quickly, very rapidly, and then it's a gradual, very slow decrease to the right. Okay. Domain here, what are our possible x values? Well, it's everything, negative infinity to infinity. That hasn't changed. Range is actually the same whether we're talking about growth or decay. We can't hit 0, but it's going to be everything that's positive. So we're going to talk 0 to infinity, parentheses on both. And yes, the parentheses on the 0 matters. And well, actually a parentheses on, or a bracket on infinity would just cause your problem to be wrong. So don't do that. All right. Let's talk about the asymptotes again. That's actually going to be the same thing. There is a horizontal asymptote right here on the x-axis. Our graph is going to approach it, but never touch it. And that equation is y equals 0. X-intercept, yeah, because you never touch the x-axis, there is no x-intercept. Okay, there's just none. Y-intercept, we can use the exact same logic. That would tell us the point 0, 1 works. And I believe we have 2 more, which is increase and decrease, and then the end behavior. So this graph, if we look at decay, is constantly decreasing. So from left to right, this graph is constantly dropping. So we're going to come down here to interval of increase and decrease. We're going to go ahead and say this is decrease. And it is from it's the entirety of the domain. So it's going to be negative infinity to, and wow, that's a horrible infinity sign. There we go, slightly better. So it's decreasing across the entirety of the domain. Last little bit here is going to be end behavior. I'm going to do myself a favor again and just redraw it. Makes life a little easier to see it. Looks something like that. All right, so end behavior here, we've got as x approaches infinity, and I called this one g of x. So if we look as x goes to the left, where is this purple curve going? Well, the purple curve is approaching the x-axis, which means its y value is approaching 0. And the other half is as x approaches negative infinity. So if we look to the left here, as we go further and further to the left, this graph is increasing. And so we're going to say g of x is approaching infinity. All right, so that's all the key features for your exponential growth and decay. Please let me know if you have any questions. I'll pop up a separate video for the 2 practice problems that have specific values in them.